Now, welcome back again the industrial biotechnology course. Now, slowly we are entering into the main topics, because now I am going to discuss about the overview of the fermenters, how the fermenters looks in the industry. And fermenters is the crucial part of any fermentation industry, that and this gives our desired product. And let me tell you again that main advantage of the biochemical process as compared to the chemical process is that biochemical process, one particular compound, organic compound, can produce n number of products, whereas in the chemical process, as the product changes, your substrate also changes. And another advantage of the biochemical process is that it is operated at ambient temperature and atmospheric pressure. The one typical disadvantage of biochemical process is that most of the biochemical process we require the sterile condition, what the chemical process they don't require. This is only the drawback that we have with the biochemical process. Now let me give you some overview of the process, and this is the schematic diagram of the bioreactor. This I explained before also. I don't like to discuss this again. So only I want to show you that what are the major component is there. This is the motor is there. This connected with the impeller, and main purpose is to start the liquid. What is the purpose of starting? To keep the solid, keep the homogeneity in the reaction mixture. I can give you a typical example here. Suppose when there is the starting, though it will be started like this. So one thing I want to point out, that when you have one blade like this, it will mainly the agitation will be this portion, not this portion. So for this portion agitation, again you should have another blade, so that that they will be starting this. So there is a multiple arrangement of the blade. So here you can see here that you have so many blades are there. This is not a single arrangement, different arrangements to have the homogeneity in the reaction mixture. And plus we have this is the sparger. This is for sterile air is required. Most of the biochemical industry, they are operated under aerobic condition. And I mentioned that organisms, they take the oxygen that is dissolved in the liquid. So you have to sparge that. There is a sparger, different type of spargers are there. Then there the harvesting is very much required, because after the fermentation is over, you have to take out the media. How we can take out the media? But what we do, we have aeration, and we close this outlet valve. And if you close this outlet valve, then what will happen? There will be air pressure here. With this air pressure, it will drag the liquid through this valve. This is usually the gate valve. There should not be, there should be very little resistance here. This will take the material from the fermentation plant to the recovery plant. Recovery plant means that where the purification of the product takes place. So you have to take this after the fermentation of the process. You have to take the material from there to the recovery unit, and you have to several arrangement we have. We have some monitoring system. We have temperature monitoring system. We have pH monitoring system. We have dissolved oxygen monitoring system. We put some kind of sensor here, what we call antifoam sensor, which is connected with the antifoam oil tank. So as soon as foam touch the antifoam sensor, the pump connected with the antifoam tank, that will be energized and drag the antifoam oil in the inside the fermenter, so that your foam will be subside. So these are the couple of arrangement we have in the fermentation industry. Now before we go in details about the industrial fermenters, we should have very clear cut conception that what our lab fermenters have, because this is in the basically that industrial fermenter is the replication of the lab fermenter. Only some portion of that might be modified, but whatever requirement we have in the small reactor, laboratory fermenter, similar requirement we have for the industrial fermenter. Now this is kind of simple example that we have here. You can see this is the vessels, and this is there are different arrangement. This is called air spurger. Can you see it? This is the filter, air filter for sterilization of the air, and then we put some kind of non-return valve. This is very much important because if there is a power failure, then what will happen? That there is a possibility when liquid can come here and enter into the air filter, and if it enters the air filter will be ruptured, or the contamination will take place. So for that we keep non-return valve. And this is the agitator shaft. This shaft is a little bit different from the normal rod that we have. It should be perfectly straight because it passes through a mechanical seal, and mechanical seal is the very important things that we have in the fermentation industry, because one is the moving part, another is the stationary part. So there is every possibility that some air can enter through this system, so it should be perfectly sealed so that no air can go inside the system. Then here we have some heating arrangement. What in the industrial level we do it in different way. We have some, I shall show you how we maintain the temperature in the industrial fermenters. Then in the exhaust you can see that we have a condenser here. The main, there is the air filter, then this is connected with the condenser. Why we put the air filter? The reason is that, so again if there is a power failure, that air can go enter into the fermenter. If air enter into the fermenter, then again contamination of the fermenter will take place, and that causes that will affect our fermentation process to a great extent. So this is the temperature monitoring system, what we call thermostat, and then we have this is the safety, what we call pressure regulated valve, that as soon as that pressure increases to a great extent, easily this is blow, so that no hazard take place inside the system. So this is always we have safety valve, because this always we have in the industry. And this is the motor for the operation of the this shaft, that we have the motor and other things that we have. Now this is the bioengineering fermenter that is in operation in our lab. You can see this is the control module where we can monitor different parameters, like we can monitor temperature, we can monitor agitation speed, then pH of the system, dissolved oxygen concentration. All these things you can monitor this process, that different monitoring system that we have here. And this is another fermenter we have. This is New Brunswick fermenter. That also, this is the control module, and this is the fermenter. We have different parameters that is listed here. You can easily visualize that what are the values of the different parameters, and online you record the change of the parameters, which is very much important for our research purpose. And this is how the fermenters look, in the small fermenters, lab fermenters look. Now industrial level, the fermenters is like this. This is the big fermenters. You can see that this is the eyeglass, that one we have this eyeglass this side, another we have another this side. Though we put some light here, and so that other side we can visualize what is going on in the system. Because if you look at our lab fermenter, this is made of glass, so you can easily see from outside what is going on inside the fermenter. But in case of industry, this is the material of construction is mostly the stainless steel, and so we cannot, is not visible from outside. So you can if you have the watch glass, through the watch glass you can visualize that what is going on. And this is the agitator, and this is the mechanical seal that we have. Now here I want to point out that that power requirement is more or less for because that mild agitation. We have mild agitation and vigorous agitation. The mild agitation power requirement approximately 1 HP per cubic meter volume of the reactor, and this is about 3 HP, more than 3 HP that per cubic meter volume of the reactor. So that about 2 to 3, that higher that power required. Now, as I told you, I work with citric acid industry, and our capacity of the vessel was 200 cubic meter. So the power drawn by the power required for the agitator was around 200 HP. It's very high, very huge amount of power we will have to apply. So this and this power, if we directly apply to the shaft, we can imagine what should be the velocity of the agitation speed will be tremendous high. So what we do, first we put the power in the gearbox. In the gearbox, we stepwise we reduce the speed, and ultimately that whatever speed we want, we transfer into this particular shaft. So whole gear box that is usually submerged in the antifoam oil tank, because this oil actually that because but if gear they are connected with each other, and they have tremendous friction, and due to friction it will generate a lot of heat, and so and oil has fire point. If you allow it to increase the temperature after some time, that it will catch fire. So what you have to do, that you have to take the oil out and pass through the cooling system. Again it will recirculate in your gearbox, so that you maintain the temperature. Though this is very much required, and this is applied in the industries. Now let me discuss the accessories of the fermenter, which is very much required. The aeration loops, that is primary purpose of aeration is to provide the microorganism in submerged culture with sufficient oxygen for metabolic requirement, because this oxygen is supplied with the help of compressor. It is a mechanical device that increases the pressure of the gas by reducing its volume and force more and more gas in the storage tank. So we can pass, as per our requirement, we pass the compressed air through the air filter and air sterilizer, then we pass it to the fermenter. So this is very much required. This we shall have to optimize. This depends on the mass transfer coefficient of the system, and the flow rate of the air, that is usually determined with the help of rotameter. Rotameter looks like this. You can see in the rotameter they have a linear scale. This is a linear scale, and there is a float. This is a small ball. You can see when air comes here, it will, as your flow rate increases, this ball will float more. It will go up and up. Though it is a device that measures the flow rate of fluid in a closed tube by allowing the cross-section area of the fluid travel through to vary, the causing the measurable effect. So whenever we use any kind of rotameter, first we shall have to remember, we shall have to calibrate this rotameter, because any kind of meter that we use for any fermentation industry, so we shall have to calibrate first. So calibration means whether the reading that is showing that is in the calibrate in the meter, whether it is proper or not, that you have to find it out. So you have to, how you can calibrate that with the help of gas flow meter. With gas flow meter you can find out what is the flow rate of air. So then you can find out, this is like this. So you can plot this flow rate, and then you have linear scale. The linear, this I want to say, this is the linear scale. Now suppose if you here this is 0, this is maybe flow rate. You can have the 1 liter per minute. This might be 2 liter per minute. It might be 3 liter per minute. Like this, you can have. So you have linear scale also. You have value will change like this. So you have like this. You have linear scale like this. So from that, when you operate that, so if you suppose it is here, so from the if you have this calibration curve, you can easily find out what is the actual flow rate of the air. So rotameter is largely used in the fermentation industries to find out the flow rate of the air. Now in the chemical industry, that here I want to point out that for the flow rate of the gas, when have a very high flow rate, we use different type of flow meter, what we call venturimeter, orifice meter. Those are the different type of flow meter that we use in the chemical industry when we have the very high flow rate. Now and then we have the air filter. The air filter is a device composed of fibrous material which remove the solid particles from the dust, pollen, molds and bacteria from the air. Because this is very important, because in the fermentation industry, that air contains a lot of particulate matters, and particulate matters, they are the carrier of the microorganisms. Now if you don't take out these particulate matters from the air, then what will happen is easily enter into the process, into the liquid. And in the media, if contains this particulate matter, contains the cells, it will contaminate the system. So you have to remove it. Now I say this is for the removal, we use the kind of filter, because this is kind of different type of fibrous filter we use, particularly glassule fiber we use for the removal of the pollutant present in the particulate matter present in the air, that is largely used. So this I shall discuss in details when I shall discuss the upstream processing, that where I have taken into consideration both air sterilization and medium sterilization. So next is the non-return valve, because non-return valve looks like that you can see that the liquid can flow this direction. If it follow this direction, this valve can open, and this is open. But if it flow this way, valve cannot be open. And I told you this is usually we keep it in the air inflow line, because why we put in the airflow line, because if there is a power failure, there is every possibility the liquid present in the media present in the fermenter that may go back to the system. So that is why, to stop that, we should have non-return valve. The non-return valve, also called one-way valve, normally allows the fluid to flow through, and it only one direction. The purpose of the check valve is to prevent the accidental reversal flow of liquid or gas in a pipe due to breakdown back to the pump. So it may happen for several purposes. Breakdown also it can be happen. Now next is the mechanical seal. I told you the mechanical seal plays very important role in the fermenter, because here in the agitator, here we have this in connection between the motor and this shaft at the outside. This is we have mechanical seal, M seal. This is the mechanical seal that we have. So mechanical seal consists of two parts. This is the stationary part in the bearing, and other is the rotating shaft. So this is the one is stationary and the rotating. So this is stationary, because you see that when you talk about your mechanical seal, that is stationary, this is fixed, and then your shaft is going inside, that is moving. This is the movable part, that is the other is rotating shaft. The two components are pressed together by spring, and sterilized antifoam oil are used to lubricate and cool the seal during the operation. Now they are tight like this, and at the same time, because if you cannot tie it maximum, because the reason is that if you tie it very high, then the friction will be very high, and if there is a friction, there will be more friction, more will be heat generation, and if the heat generation is more, it may rupture the mechanical seal. So what we do in the industry, we pass the antifoam oil, so here we pass the antifoam oil at the high pressure. Now when we pass the antifoam oil high pressure, it maintains some kind of air positive pressure inside this air mechanical seal. If there is a positive pressure inside the mechanical seal, what will happen? There is a less possibility of air to enter into the system, and this is how we can maintain the sterility of the process. And main purpose of passing this oil to do the lubrication of the shaft. If we do the lubrication of the shaft, then frictional force will be reduced, and if the frictional force is reduced, then the amount of heat generation also will be reduced to a great extent. So this is how it looks, the mechanical seal. You can see that industry how different type of packing materials they put inside, and this is the only few company in the world they can produce this kind of mechanical seal for the fermentation industries. Then fermentation vessels. I told you, in the small fermenter we usually made glass vessels so that we can see outside. But the industry we use the stainless steel, because stainless steel they can resistance the high acid concentration, because most of the fermentation process we produce a lot of organic acids, and organic acids some kind of corrosive effect on the materials of construction. So we discussed before that how the composition of the alloy steel, stainless steel, that improve the acid resistance or corrosive property of the stainless steel. So we can have it. That is why stainless steel is used in the fermentation industry. It is easy to examine the interior, because here we use the glass vessel in the lab fermenter to examine the interior of the vessel. But in the industrial fermenter we use, I told you, we have the watch glass at the top. From the top, by the help of light, we can find out what exactly what is going on inside the system. Then feed ports we have. There are so here in the lab fermenter we use the silicon tube for transferring the liquid from inside the fermenter. For the industry we have some stainless steel pipeline through which we add the nutrient to the fermentation, transfer to the fermentation vessels. So this is the feed port that we have. And the baffles, which is very important, baffles, the metal strip attached radially to the wall, and they are used to prevent the vortex and to improve the aeration capacity. The baffles maintain a gap between them and the vessel's wall to enable scouring action, thus minimizing the microbial growth on the walls of the fermenter. Let me explain that. Suppose this is a fermenter, and this is the fermenter, and we put a agitator here. So if we don't put any baffles, then what will happen? There will be a vortex formation. This is like this. We can see in our house also. When you take water in the glass and put the sugar in it and try to make a solution with the help of a spoon, then you will find there is a vortex formation like this. Now if you do the aeration here, then what will happen? What is the problem? That air that goes like this, the air is going, bubble will go like this, the bubble will travel like this. Now since here the height is less, the retention time of the bubble will be very less here, and retention time bubble will be more. That is undesirable. So in the industry, this level should be as it is. So to do that, what you do, we put a baffle here. This is the baffle on the metal strip that we put at the wall, so that if you put this strip, then there will be no vortex formation. So this is the baffles that we have here. You can see this is the baffles we have in the reactor. This is how the liquid is remaining at the same level. There is no vortex formation here. Now impellers, that is very important. They are used to agitate. I already explained to you that how the impellers, what is the function of the impeller, to ensure that a uniform suspension of the microbial cells is achieved in a homogeneous nutrient media. Now here I want to point out, you can see this is the disc, am I right? And it is connected with the different blades, and you have number is there 1, 2, 3, 4, 5, 6. So this number you can vary. You can make it 5, you can make it 6, you can maybe 7, whatever. Now, then when I work with the industry, then I find that when I told you we shall have to keep the impeller, that this impeller, that blade in the different levels. This one, because if height is more, then you have more baffles across the shaft. We have so many impellers we shall have to put in the fix with the shaft. Now this number of this blade is very important role, because we find that if this number is not optimized, there will be tremendous tremendous vibration of the fermenter. So the industry, we try to optimize that which combination we can have the minimum vibration in the fermenter, so that, because if there is a lot of vibration in the fermenter, this is undesirable, because otherwise that there again some connection will be loosened and contamination problem will take place. Then we have sparger. We can see that it is used for aeration purpose. The purpose of aeration is to provide the sufficient oxygen to the microorganism for metabolic requirement. Sparger introduce air into the liquid of the vessels. This is here you can see that air is coming like this and sparging like this, like this. Then reflux cooler, this is fitted in the outgoing stream of the air, because if you allow the air to go out of the reactor, then when it passes through the reactor, then your air will be saturated, and but then slowly you will find the volume of the fermenter will go down. Then because if you want to maintain the volume of the fermenter same, then there should be the condenser at the exit of the air stream, so that you can condense back the vapor to the reactor again, so that your volume will remain constant. Now this is the exhaust air filter. I told you this is just to stop the contamination problem we have in the exhaust stream. Safety valve is very much required, because if due to some other reason the pressure inside the reactor increases, there is every possibility of hazard that may take place. For that we know that in our regular use in the home, that pressure cooker we have a safety valve, because the same in the industry also we require the safety valve for the safety measurement. Then we have the temperature loop, we have heater and cooling finger, and that cooling heater, because I can tell you that in the fermenters we usually put the jacket. It is jacketed and we pass the water like this. Now if you do this, there is every possibility of channeling effect. So what we do in the fermenter, basically, that we have pipeline, they wrap on the surface of the fermenter like this. So we pass this pipeline across the fermenter like this, so that water goes uniformly through the surface of it, and it has some kind of cooling effect. So both the cold water and hot water we can send through this as per our requirement. This is the pH probe used in the fermenter, which is different type as compared to the normal pH probe. You can see that because when you use inside the fermenter, this should withstand the 15 psi pressure, because usually the sterilization takes place at 15 psi pressure. And if you because the specialty is that we maintain some pressure here 15 psi with the help of hand pump, we can do that. This is so that if we don't maintain the pressure, then what will happen? The fermenter, the porous glass, inside the porous glass the liquid can enter and affects our electrolyte and damage the system. So avoid that. We should have some kind of pressure here. Here above the electrolytes we should have 15 psi pressure, so that no such damage can take place. This is the special device that we have in the fermenter for the pH probe. So this is the principles, and temperature probe also there, oxygen sensor also, motor and foam control device already I discussed. Thank you very much.